All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing more of a yap sesh. We're just going to be chatting about. So I got a small chance to stream uh, for a short period of time. So I wanted to take that time to discuss sort of a roadmap of my not necessarily streaming, but like it does kind of tie into streaming as well because I'm going to be streaming whatever it is that I'm doing. So I don't know if it's necessarily a roadmap for streaming, but it kind of does affect the stream as well. So in a way, streaming roadmap, I don't know. So okay, I want to sit down and make a list of I have a list already. It's like I do this thing where I'll so I have a document where that I use as like a scratch notes notepad where I write down stuff just so I can remember it. It can be anything, quick things. Cutane, hello, hello, welcome to the stream. Appreciate the lurk. We are currently discussing. Um, we are currently discussing. What are we discussing? A roadmap for the stream. More specifically, uh, the various things that I'm planning on researching and working on and stuff like that. I got a small chance to stream during this time of the day, so I wanted to take that chance. And I might stream again later on. Later on being, I don't know, 6 to 8 hours. Not six, probably 8 hours from now. I'm probably gonna do my other study stream. This is mostly just gonna be a yap sesh, and I figured I'll just use Kaggle notebooks for writing down the notes rather than opening up VS Code. Dude, ever since I started doing this thing through Kaggle notebooks, shit is just so much more smoother. Like it is crazy, dude. It is insane. It is insane how much how much better the performance is. Like right now, the two windows that are being captured, that are being shown on stream are they're both browsers. One is a main browser window and the other is a private browser window. And they're not killing the performance nearly as much as if I was capturing VS Code. And of course, I'm capturing my own VTuber program as well, which is also not taking up too much in terms of performance. So like in in terms of doing data science stuff, I'm really leaning a lot more towards just doing all of the stuff through Kaggle. And even if I have like some personal data sets, because Kaggle allows you to upload private data sets. So even if I have some personal data sets that I don't necessarily want to make public or I cannot make public for certain reasons, um, I can upload those to Kaggle and I can still work with them through Kaggle notebooks. Um, so yeah, yeah. Why was I talking about this? Oh yeah, just the performance of Kaggle notebooks. I was also mentioning the scratch notes notepad that I have, where I note down stuff just so I can remember it later on. It can be anything from research to stuff that I have to do, stuff that I have to focus on, stuff that I want to focus on today specifically, or stuff that I want to focus on like in the long run, and all of that stuff. It's sort of my own thoughts slash reminder slash to do list. It's like a combination of the three of those. And it helps me remember stuff because if I don't write the shit down that way, I'm definitely going to forget it. I'm not going to remember it. Okay, that being said, let's discuss the stuff that I need to currently be focusing on. There's certain things that I need to be focusing on that I'm not going to be writing in this list for certain reasons. But um, there's a lot of stuff that I can write, so I guess I'll write that. So, uh, first in the list is just basic data science stuff. Yeah, basic data science stuff. And here we can have sort of a, we can give a bit of an explanation of like, okay, what topics am I trying to look at? So we can have basic stats, right? And then I want to look into clustering, and then I want to look into generating, well, not just generating, but studying distributions. Pre-processing is another thing I want to look into. And all of these things I've kind of already started looking into them. It's just that listing them out in this way, it helps me remember it. Because the way that my mind works, I tend to branch out a lot, and once you branch out enough, you'll kind of forget the previous stuff that you were doing. You kind of lose track of what brought you to where you are, in terms of, like, I was researching this, and then I didn't get distracted, but I branched out and then started researching that and that. And then I branched out from that and that and started researching that and that and that and that and that. Like, there's eventually you branch out so much that you kind of just lose track of all of the other things. And I like to keep track of all of the other things as well. Because all of these things are equally important. So, okay, if we take a look at the scikit-learn documentation, because, dude, okay, so I really like going through scikit-learn's documentation because it introduces me to a lot of data science related topics, a lot of data science and stats related topics that I didn't know before. And like, some of it may not necessarily even have anything to do with machine learning. I mean, it can be tied into machine learning somehow, but like, its main use isn't necessarily always machine learning. Like, data science isn't always machine learning. There's a lot of other stuff that goes around, that goes what am I trying to say here? There's a lot of stuff there's a lot of other stuff that is involved in data science. It's not just ML, but data science is heavily used in ML. I want to explore all of the other sides of data science as well, not just sticking with ML. I want to study the ML side as well, but I want to focus on data science, not just focusing on ML. And that means that I have to look into a bunch of these different topics because I'm interested in studying data, studying data sets, and studying their behavior, the patterns that they form, the relationship between the different variables, how one variable depends on another, if it depends on another, how much changing one variable can change another variable, and just learning as much as I can about a given data set. It can be, and even the data set can be anything. It can even be, like, it can be sales data, right? It can be something like, I don't know, video games that have been released. It could be trading data. It could be, and in trading data, it could be like, a bunch of different topics. Like, there's a bunch of different things that get traded, not just stocks, right? So it could be a bunch of different types of trading data. It could be, shit, I can just go through the list of data sets that are available on Kaggle to give you an example of what all could be available. Okay, let's open up data sets here. Okay, just going through this list. Let's take a look. So, Goi Bibo flight data. I'm not sure what that is. Maybe that's some kind of airlines. Oh, is it supposed to be Go Ibibo? What is that? Hold on. Ibibo. best travel website, book hotels, flights, trains, bus, etc. For what country is this? Is this in... Give me a second. Country. India. Okay. So this is to do with traveling in India. It says Goibibo is India's leading online travel booking brand, providing a range of choice for hotels, flights, trains, bus, and cars for travelers. Okay, all right. So this is one example. Another example is this, what I was talking about with in terms of trading, right? And then there's a community health evaluation data set. Let's open this up. Let's take a look at... Oh, League of Legends Worlds. I think this is some esports thing maybe. GeoGuessr user IDs data set. What is this? Also, Pokemon. Okay, look at that. Pokemon with stats and image. Somebody made a data set for that. How cool is that? This is a data set. Oh, chill out, chill out, chill out. Okay. Um, what was I doing? Yeah. This data set is 1,215 Pokemon from generation 1 to 9 and the accompanied image. The data was gathered September 2024 from so and so. Okay. The dataset is split into two main parts, a CSV file with stars about... Oh, I think they meant stats. Yeah, that's a typo. With stats about each Pokemon and an image folder with one so and so. Oh, okay. So the CSV file probably references something in the image folder. How's it referencing? Hold on, I'm curious about that. How's it referencing the data, or how's it referencing the image? Oh, it's a path. It's a path to the path to an image of the Pokemon in the images folder. Okay, all right. So I mean, the path was like the first thing that came to my mind, but then I was like, could there be another way that they might be using it? Like maybe somehow they managed to create like an index-based thing. Give me a second. But okay. Let's not get too distracted from this. No, let's not get too distracted with this. Um, my point was that... what was I talking about? Oh yeah, that I like to try and find patterns in data. I like to study data sets, and that's why I want to study data science as well. Just data science in general, not necessarily only machine learning and deep learning related data science, but yes, I do also want to learn machine learning and deep learning related data science because I'm learning deep learning. Um, right. So, bunch of things here. Clustering is some... there's topics that I haven't... I think, okay, maybe what I should do is I should... So these are the topics that I know about, right? Maybe I can add here other sklearn... No. Other stuff. See sklearn docs. Okay. Right. So this is our basic data science stuff. In fact, some of this, to be honest, is not basic. I just realized I made a typo in science. Okay. Some of this is not basic. It's some of this does actually go into advanced stats and even advanced like data science stuff, but like I was just calling it basic because I'm still a beginner in data science. Now, okay, data science is one thing, right? Another thing I want to do, I want to start doing more stuff on Kaggle. I had some ideas for data sets that I could create. And these are going to be data sets that follow certain patterns, not just generating random data. But I need to study. So this is where distributions comes in, because one of the reasons I'm trying to study distributions is because I feel like when you are generating data that's random, it can be different. It can give you different results compared to if you're generating data that is along a certain distribution. So, for example, some there's one random method. There's one method for generating random data. I think it's in NumPy. I think it's in NumPy. And this method generates random data along a normal distribution. So, given enough points, I feel like if we plot you know what? Okay, I'm curious. I haven't tested out this theory, but because it said it's a normal distribution, and a normal distribution always follows a certain shape. It's sort of a bell curve type shape, but also there's certain statistics about the entire data set that kind of prove that it's a normal distribution. But I'm talking about like the bell curve. I wonder if I would be able to generate, like, given enough samples, if I generated enough samples and then plotted them all on the, oh, actually, no, I wouldn't. Oh, I would need to generate the samples and then sort them and then plot them. Yes. So I wonder if I did that, would I somehow get a bell curve? Let's generate a sample. Let's generate a data set of, I don't know, 20,000 samples. So let's say A equals np.random dot, is IntelliSense gonna work? I'm not, it should work, right? Yeah, there it is. Okay. Random. I don't remember if it was rand. This is a convenience function. Okay, then let's do random. Random floats. Nope, this wasn't it either. What about rand? And I just realized, I think the n might be for normal distribution. The n at the end of rand n. I don't know. I'm not sure. Maybe it might be for normal distribution. Okay, so what exactly does this say? It returns a sample from a standard normal distribution. Okay, I know what a normal distribution is. I don't know if that is also called a standard normal distribution. I'm going to have to look into that. But for now, let's try generating this. Let's generate. Okay, so let's create an array. In this array, we're going to use list comprehension to generate this. So it's this for, that doesn't matter, in range. I'm glad that I learned about this operator. I forgot what this is called. In C#, I think it's called the discard operator, but like in Python, you can use it to like substitute like empty spaces where something is not supposed to, where there's no value expected. I think you're able to do that in C# as well. Yeah, yeah. Where was it called the discard operator? I think I'm remembering something else. Don't just forget I said the discard thing. I'm gonna have to look. No, you know what? I'll look into it right now. Hold on. Uh, C# discard operator. Well, yeah, there it is. Discard underscore. Discards are placeholder variables. Oh, okay. All right. Fine. Great. Cool. So we can move on from that. And here I'm trying to generate, let's say, 20,000 samples. Okay, and then I also want to sort this. Now, what does sort return? Sort, I believe sort is a like in place operation. Yeah, I believe this is an in place operation. It doesn't return anything. So that the variable is going to be sorted. Let's get, did I say the variable? The array is going to be sorted. So let's try to get, I don't know, the first 10 values. Is that how you index NumPy arrays? No, that's probably not. Oh, wait. Um, since this is an in-place operation, I think I need to do it like this. Yeah, there it is. Okay. Uh, this has been sorted. Great. Cool. Awesome. So now we can plot this on a scatter plot. I don't remember if the scatter plot automatically assumes. Oh, you know what? We could do a line graph. It doesn't have to be a scatter plot. We could do a line graph. So let's do plt dot plot a, and let's see what that looks like. Oh, that's interesting. I was not expecting that. That's what it looks like. Yeah, so what I was expecting was more of a bell curve sort of thing, like something going like that. But this seems different. I think I should look into this. Oh, let me try asking. Wait, what's the last thing that I asked? Perplexity? Oh, okay, yeah, it was about the scaling and stuff. Yeah, dude, after yesterday's stream, I did continue looking into this, and then I kind of got distracted and went and looked at something else. But I did look into this a little bit, and it's kind of interesting learning about how values can be scaled using these scaling things. Like one of the things that I was able to do just following this code is I was able to transform this data. It's basically what this code is doing. I was able to transform this data, or well, given a data set, I was able to transform the data set such that its mean becomes 0 and its standard deviation becomes 1, which I think they call that unit standard deviation, or I think the variance becomes 1. I don't remember. No, that it's a standard deviation. Becomes 1. I found that interesting, like being able to scale an entire data set's values such that it fits a specific requirement, let's say. And if we are able to do that, if we are able to do that, where was I going with this? I forgot. If we are able to do that, then I wonder what more we are able to do in terms of transforming data or even just processing data. Give me a second. Okay, I just realized we were supposed to be discussing the stream roadmap. Let's carry on with that. I'm gonna look. Oh wait, yeah, hold on, real quick. I'm learning data science. What is the difference? Hold on, there's a couple of typos. What is the difference between a normal distribution and a standard normal distribution? Okay. Um, to understand the difference between a normal distribution and a standard normal distribution, here are the key points. A normal distribution, also known as a Gaussian distribution, is a probability distribution characterized by its mean and standard deviation. It has a bell-shaped curve that is symmetric around the mean. The mean, median, and mode are all equal and located at the center of the distribution. The spread of the distribution is determined by the standard deviation, and the probability density function of a normal distribution is given by so and so. Okay. Standard normal distribution is a special case of the normal distribution where the mean is 0 and the standard deviation is 1. It is also known as the Z distribution. The probability density function is so and so. Okay. Key differences: the mean and standard deviation. The primary difference is that a normal distribution can have any mean and standard deviation, while a standard normal distribution has a fixed mean of 0 and a standard deviation of 0. Wait, back up, back up. A normal distribution can have any mean and standard deviation, while a standard normal distribution has a fixed mean and a standard deviation of 0. Okay. Conversion. Any normal distribution can be converted into a standard normal distribution by transforming the data into z-scores using the formula so-and-so. Oh, so z equals, I guess, x minus the mean divided by the standard deviation. Okay, good to know. This transformation standardizes the data, allowing for comparisons across different distributions. All right. Okay, so a thought just occurred to me as I was reading that. I was like, okay, if we are able to transform this data into another form and then use it for, something, what if we need to transform it back? But then I realized that there might be situations where you don't intend to transform it back. You are transforming it so that you can use it in methods and algorithms that will give you information about the original form, about the original data set. So you don't necessarily always need to transform it back. Yeah. Yeah. Okay. I should keep that in mind because I feel like that same thing can apply to a bunch of different scenarios, data science related scenarios. Okay, applications. The standard normal distribution is particularly useful for calculating probabilities and comparing data points across different normal distributions. Interesting. Calculating probabilities and comparing data points across different normal distributions. Oh, because it standardizes all of them? Okay, all right. It is often used with Z tables to find probabilities of events occurring within certain ranges. Okay, so I need to do research on both of these things. Z scores and three things. Z scores, Z distribution, and what is the other one? Z tables. Events occurring within certain ranges. Okay, for example, if you have a data set of exam scores with a mean of 80 and a standard deviation of 10, you can convert these scores into z-scores to compare them to the standard normal distribution. This helps in understanding how many standard deviations away from the mean. No, wait. How many standard deviations away from the mean a particular score is. Okay, all right. The z-score of this z-score of 1 indicates that the score of 90 is one standard deviation above the mean, which corresponds to copy copy probability. No. Oh, my mouse my mouse was over this thing. So I thought it was okay, whatever. Specific which corresponds to a specific probability in the standard normal distribution. Okay. So let's ask this question. What are z scores, z distribution, and z tables? Now, while it answers this question, I think I'm going to start the ad break because the ad break is going to start in like, I don't know, 25 seconds now. So I'm going to start the ad break now and I'm going to take a little hydration break. So I'll see you guys in 30 seconds. All right. Welcome back. Oh shit, I forgot to hit enter. Okay. All right. Whatever. So this is going to give an entire answer. I also just realized that we strayed away from this list that we were making. So let's carry on making the list. That thing is just gonna finish its entire answer and then I'll read that in a bit. So okay, on Kaggle, I want to try making some of my own data sets. Dude, okay, I feel like different people are able to contribute different types of data sets, be it real world data sets or synthetic data sets that are just meant for you to be able to study and explore. Because I'm sure the synthetic data sets also they get used in various ways. I'm guessing a couple of Kaggle competitions have used synthetic data sets as well. It doesn't necessarily always have to be a real world data set, right? And when we talk about synthetic data sets, I feel like the different backgrounds that different people have, or rather the different experiences that different people have and the different types of knowledge and interests that different people have make it so they would each be able to generate their own unique types of data sets. And it's the same case with me. I have knowledge of certain things, certain real world things, and in terms of businesses, I have I have real world knowledge of the behavior of certain types of clients, the purchasing patterns of certain types of clients. So I would be able to write some code to sort of model that behavior and generate a data set based on multiple such behaviors. I want to try doing that. There's a couple of other things as well that I want to try making data sets on. This is not all going to happen at once. It's going to be like very incremental, and it's going to be way down the line. It's probably not going to be anytime soon because I still have like a shitload of things to learn. I mean, I'm going to try making the data sets. So okay, I feel like I feel like I should mention this as well. I'm not just planning on generating the data sets. What I want to do is I want to provide notebooks so that people can generate their own data sets, if that makes sense. And of course, I can generate some data sets as well, and put them up. But then I also want to provide the code for people to be able to generate their own similar data sets if they wanna study different types of behavioral patterns. So yeah, let's see how that goes. I don't know at what point I'm going to be doing. I'm going to be doing that, but I do want to do that. At the very least, even if I don't give the code, I mean, I don't see a reason why I cannot give the code. It's just that the thing is, if I'm writing code where it's just the output that I'm going to be posting, then I don't care if the code is structured properly. I don't care if the code is a mess or whatever. I'll just write the code, right? But if I'm writing the code so that other people would also be able to use it, then I would feel the need to structure things a little bit and maybe add some notes here and there as well. Though, okay, to be fair, in general, when I do this kind of stuff, if it's like a bigger project that's going to be using Jupyter notebooks, if it's a bigger project that's going to be using Jupyter notebooks, or if it's like a bigger task that in which I'm using Jupyter notebooks, I do make use of both comments and the markdown cells so that I can add as much detail as I can, and then in the code also I'll make use of comments so that I know what the code is doing. But I'll use the markdown cells to understand what the entire cell is doing. So that way I'm able to divide this entire big code logic into multiple blocks, and I know exactly what is going on. And I can also make it kind of modular. It doesn't all have to execute at once. That's one of the great things about Jupyter notebooks, is that you're able to divide the code up into multiple cells. And I've done this. I've done this with a couple of other projects that I worked on. Other like real world projects that where I was building tools or doing some kind of data visualization or whatever. I I generated No, I didn't generate. I later generated an entire Python file, which is another great thing about Jupyter Notebooks is that, okay, I'll get into that in a bit. So I've done this thing with like bigger projects where I've divided the code into code blocks, into multiple blocks. And sorry, what was I saying? Yeah, I've done this thing where I've divided code into multiple blocks, so the code is modular. So I know that, oh, this block does this, that block does that, and I don't have to execute everything at once. And in some cases, that can actually be very useful. I can't give like good examples, but like one example would be a situation where you want to generate a new version of a certain data set, right? But you don't want to have to rerun the entire code again, like all of the code again. You just want to rerun those few lines that generated a certain random data set for you. Yeah, yeah. Okay. So, I was also talking about Jupyter Notebooks, right? Jupyter Notebooks. Something I like about Jupyter Notebooks is that it gives you an API to directly interact with the notebooks. So I was able to do this thing where I created I created a Jupyter notebook with all of the code logic in the code cells, right? And then I created a Python script that read that Jupyter notebook and extracted all the code cells or extracted specific code cells from it and just created one big Python file out of that. So I was able to extract the code from the notebook and sort of generate one Python file that would then be executed. So that way, when the other machine or when the target machine, the user, the end user who's going to be using that code, when that person is running the code, they don't need to have Jupyter notebooks. They don't need to have Jupyter notebooks installed. All they need is the Python environment and Python. They need the specific Python environment because there's still like certain modules, certain libraries that are required. Give me a second. Give me a second. I'll be RP. Okay. So I need to end the stream. Sorry for the abrupt end again, but yeah, I need to end the stream. I'll be streaming again in like maybe 8 hours. And then we're gonna do more data science stuff. Or maybe we'll carry on doing this roadmap thing because we are not done with it. But yeah, I hope you guys have a nice day, and I'll see